As Arthur C. Clarke once said, any sufficiently advanced technology is indistinguishable from magic. It's a statement that challenges the way we perceive what is possible and reminds us that what seems miraculous might simply be misunderstood. Imagine, for instance, showing a smartphone to someone from the 13th century. To them, this glowing rectangle that speaks and shows moving images would not just be advanced, it would be perceived as sorcery. Yet today, we know it's grounded in logic, physics, and engineering. The same principle applies contemporarily. We may encounter effects without grasping their underlying mechanisms. However, there is an interesting corollary to this that takes the idea a step further and is also grounded in current objective empirical observations. The idea that any amply advanced technology may be impossible to distinguish from nature at all, and that intelligent life with a head start of just a few million years may be completely unrecognizable within our current cognitive and conceptual frameworks. Consider the way non-human animals perceive human technology. A domestic cat, for instance, does not register a car as a vehicle engineered for the purpose of transportation, nor does it grasp the functionality of a toaster or a TV. To the cat, these are simply static features of its environment, neither meaningful nor artificial. Not because it lacks the senses to observe them, it sees and hears just fine, but because it lacks the cognitive frameworks required to attribute purpose or origin to such objects. This does not merely imply that aliens might be unrecognizable in appearance or culture, but that the very nature of sufficiently advanced intelligent life could be so far beyond our cognitive, perceptual, or technological capacity that we simply lack the mental architecture to even identify it as life at all, or its artifacts as technology. Under this interpretation, they're here, but we're no more able to detect them than a dog has awareness that it lives in an intelligently constructed environment. It navigates roads, rooms, and architecture without any comprehension of their artificial origin or underlying purpose. Similarly, a deer crossing a highway doesn't recognize cars as human-created artifacts. It reacts to them as part of its environment, no different from trees, rocks, or other animals. This is one of the more underappreciated explanations to the Fermi paradox, the notion that if intelligent life is not unique to Earth, then by all mathematical expectation, our galaxy and even the observable universe should already be dominated by it. The Milky Way alone contains roughly 400 billion stars, many billions of which are older than our sun and host Earth-like planets. If even a single civilization had arisen just a few 100,000 years prior to our own existence, what amounts to a rounding error in a cosmological timescale, they would have had amply sufficient time to colonize, engineer, or transform vast regions of our galaxy and surrounding supercluster. This implies that either intelligent life is far rarer than we imagine, or that our assumptions about what intelligent life looks like are profoundly limited. Perhaps the reason we don't see them is not because of their absence, but because we no longer have the conceptual capacity to identify what they've become. If we recognize the fact that an octopus or a cat can't conceive the purpose of a rocket ship or a TV, what does that say about us, relative to intelligent life with a 10,000 or 10 million year head start? To understand the scale of that difference, we only have to look at ourselves. For roughly 300,000 years, over 95% of our species' entire existence, humanity was technologically stagnant. Generation after generation lived and died using the same stone tools, the same fire, the same patterns of subsistence. Progress was so slow it could take tens of thousands of years for a single minor innovation to spread. Civilization, the rise of cities, writing, and nations, has existed for barely the last 5% of our timeline. The Industrial Revolution, the beginning of mechanized technology, has occupied only the last 0.1%. In the digital, networked, information technology-driven world we now inhabit, it emerged within the final 0.001%, an eye blink in evolutionary time. In that infinitesimal moment, we went from lighting fires to manipulating atoms, from drawing on cave walls to simulating entire realities. We are no longer evolving biologically, we're evolving technologically, and that evolution follows not a straight line but an exponential curve. Now extrapolate that curve not by decades, but by thousands or millions of years. If our own technological trajectory continues to accelerate, what would even a few 100,000 years of uninterrupted exponential growth look like? It would likely not resemble life as we currently understand it at all. At that scale, intelligence could shed its biological origins entirely, integrating with its own technology, becoming computational, post-physical, and perhaps indistinguishable from natural phenomena itself. It could operate on substrates, timescales, or principles completely foreign to us, Just as our own modality of being or intelligence is so utterly alien to other animals that they're unable to discern when they're in the presence of our technology. This introduces the notion that more advanced life might manipulate reality in ways we classify as natural law, and that we likewise might look at, say, dark matter halos, strange quantum decoherence zones, or information theoretic anomalies in cosmic background radiation, and think they're just physics, when in fact, they might be artifacts or infrastructure of transcendent technology. Think of it like this. Every technology depends on conceptual scaffolding, the network of ideas, discoveries, and abstractions that make its design intelligible. An observer can only understand a technology if they possess the conceptual prerequisites for its purpose and function. A species must first understand why a technology exists before it can recognize what it is. Without the underlying concepts of, say, atoms or space, the purpose of an artifact is not merely misunderstood, it becomes incomprehensible in principle. That is to say, forms of life that are separated by vast developmental timescales become causally decoupled in their experiential reality. In their lived worlds, the causal structures that define their existence no longer meaningfully overlap. Thus, technological recognition is not a function of intelligence alone, but of causal embedding, and whether two forms of life inhabit overlapping causal worlds, an interval that may be unimaginably brief. Even evolutionary timescales of just a few million years, the difference between early hominids gazing from the trees to humans venturing into space, can represent a total discontinuity in perception. The younger species' entire ontology may lack the categories required to understand the older one's behavior, purpose, and technology. If intelligence evolves along this kind of trajectory, as our own experience suggests, then the absence of visible technosignatures from alien civilizations becomes not surprising but inevitable, as any shared frame of reference would dissolve completely on even minute cosmological timescales. Our prevailing conception of advanced extraterrestrial life, characterized by interstellar travel via starships and galactic colonization, is an anthropocentric projection of humanity's own technological infancy. It is a linear extrapolation bound to biological form, material constraints, and expansionism, when in reality, intelligent life may have long since transcended physicality, biology, and our current notion of civilization itself. This extrapolation of currently observed evolutionary patterns on Earth, which have now been dramatically accelerated by the creation of technology, introduce an important shift in the framing of the Fermi paradox, that the problem may not be one of distance, but of developmental alignment, and the extraordinary improbability that two alien civilizations would find themselves in the same fleeting window of mutual intelligibility. Even under the supposition that the desire for communication existed, the cognitive gap between humans and even our most recent evolutionary relatives shows us that this is likely impossible in any meaningful capacity. Their conscious experience, their perceptual world, and the scale of their intelligence is so different from ours that the prerequisites for communication don't exist on any practical level. A chimpanzee may be able to learn symbols or respond to gestures, but it does not have a theory of mind robust enough to truly model our intentions, nor a linguistic system complex enough to convey recursive layered meaning. Its world is constructed from patterns of sensation and behavior, not from formal abstractions. And for anything sitting markedly below them on the scale of intelligence, insects, reptiles, and so on, communication in any form, meaningful or not, is basically a non-starter. At that level, it isn't merely that communication lacks any remotely significant range or depth, but that they lack the cognitive structures for shared meaning, intentionality, or abstraction, and operate almost entirely on an instinctual level. There is simply no common mental state in which even the simplest ideas could be exchanged. In the end, our search for extraterrestrial life may be less a cosmic census and more an act of self-discovery. When we ask why we do not see others, we are really asking who we are and how far we may yet rise. Until then, we remain like early hominids staring at the moon, aware of its presence, moved by its mystery, and completely unprepared to grasp what it really is. As always, thank you for watching. Please like and subscribe if you enjoyed this video, and stay posted for new content, and I'll catch you soon.